Welcome to The Explainer. Today we're diving into something pretty fascinating, a kind of hidden language. It's the special code clinicians use to literally write down sound.
So let's just jump right in with the question. How do you write down a lisp? And I don't just mean writing the kid has a lisp. I mean, how do you capture exactly what's happening with their tongue and their breath to make that specific sound?
This is where we meet Ava, who's 5 years old. Now, a clinician's job is to figure out precisely what's going on. But here's the problem. Our normal alphabet, ABC, it just doesn't have letters for things like a lateral lisp or a T sound where the tongue pokes out. So if you can't write it down, how in the world are you supposed to track it or even treat it?
Here's a great way to think about it. Our everyday alphabet, it's kind of like a blurry photo. You get the general idea, right? You can tell what was said, but for a clinician, that's not nearly enough. They need something more like a high-resolution, slow-motion video. They need to see how it was said, every tiny detail of the tongue's movement and the airflow.
So, how do you do it? How do you capture something as quick and fleeting as a single sound and do it with enough precision to actually build a therapy plan around it?
Well, they have this amazing tool called phonetic transcription. And let's be clear, this has nothing to do with spelling. This is all about writing down the real, actual sounds that come out of a person's mouth. And you know what? This skill is the absolute bedrock for diagnosing any kind of speech sound disorder. And to pull this off, they don't use the alphabet we all learned in school. Nope. They use a special alphabet, one that was built from the ground up just for sounds. It's called the International Phonetic Alphabet, or the IPA for short.
Okay, I know what you're thinking. This chart looks intimidating, right? But don't worry, the core idea behind it is actually super simple. Get this. One symbol always equals one sound. That's it. It's basically a complete map of every single sound the human voice can possibly make. Now, with the IPA, you can get really specific. There are two levels of detail. First, there's what's called broad transcription. That's when you see the slashes. Think of it as the general category, like the intended sound. But for the real clinical detective work, they use narrow transcription, inside brackets. This is where they capture the actual sound that was made, with all of its tiny and totally critical details.
So how do they get all that amazing detail? Well, to go from that general, broad view to the super specific, narrow one, they add these tiny little marks called diacritics. You can think of them as little modifiers, like footnotes, that add a ton of crucial information to the main symbol.
All right, let's see this in action. We'll start with just one sound. Here's the symbol for a typical S sound. The airflow is straight, the tongue's in the right spot, everything's working as it should.
But now, watch this. We add this one tiny little mark underneath, and suddenly it becomes a dentalized S. That tiny mark tells a clinician instantly that the tongue is too far forward, pushing right up against the teeth.
Okay, now what if we swap that out for a little J above the symbol? Now it's a palatalized S, and that means the complete opposite. The tongue is way too far back in the mouth, almost getting into sh territory.
And for a lateral lisp, like Ava's, where the air is spilling out the sides of the tongue instead of the front, well, the sound is so different it gets its very own symbol. It's not even an S anymore.
And this is why all that detail is so incredibly important. For that dentalized S, where the tongue's too far forward, what's the advice? Pull your tongue back. But for the palatalized S, where it's too far back, the advice is push your tongue forward. We're talking the literal exact opposite instructions. If you can't write down the difference, therapy is just a shot in the dark.
Now, this isn't just some abstract academic exercise. This power to see the details can completely change a child's life. Let's take a look at the case of a 6-year-old boy named Andy. See, to his teacher, Andy's issue seemed pretty straightforward. He was just swapping out his S and sh sounds for a th sound. Simple, right? But a clinician listened closely and heard something else, subtle little differences that pointed to a much more complex and actually a much more hopeful picture. And here's the absolute game changer. The teacher just heard th, but the clinician's transcription showed something incredible. Andy was actually making 3 totally different, totally consistent sounds. When he tried to say sun, he made that dentalized s. When he tried for shoe, he made the palatalized s. And when he said thumb, his th sound was perfect. The biggest takeaway? He wasn't confusing the sounds at all. That one discovery, it changed everything. The diagnosis went from this vague idea that he confuses sounds to something incredibly precise. He has specific, treatable placement errors, and that meant therapy could zero in on those exact tongue movements. It became focused, efficient, and way more effective.
So when we step back, what's the real takeaway here? What does this hidden language of speech really tell us?
It's this: phonetic transcription is what turns a fuzzy, subjective comment like, "he talks funny," into an objective, data-driven roadmap for therapy. It's the blueprint. It tells you exactly where you need to go.
But when you really think about it, these tiny little marks on a page, these symbols and diacritics, there's so much more than just clinical data.
They represent the difference between being misunderstood and being heard, between frustration and connection. They are literally the key that unlocks a person's ability to be understood and to share their voice with the world.